In this video, we are going to summarize horizontal and vertical lines. I'd like to first start by making this foldable. We're going to take this and we're going to fold the right-hand side over until it hits that line there. We're going to crease it, and then I'm going to take my scissors and I'm going to cut this so that it will open up and we'll have two different flaps. So here I'm going to lift this up. I'm just going to cut along this line. So cutting all the way only up till there. So that way when I open this, now I have two different flaps. I want to open the first one right now. And you've already graphed equations where we don't see an x, we just see y equals a number. So I want you to pause the video right now and see if you can recall, how do I graph y equals -4? You have a graph here. I'd like you to create that graph. And I would also like you to make a table. So pause the video, create the graph, and make a table right now. Now that you've tried this on your own, I'm going to talk through how I think through this. When I look at this equation, you could think of this like slope-intercept form, where this would be y equals, I don't see an x, so that would be 0x plus -4, or y equals 0x minus 4. Which means if I go to graph this, this has a slope of 0 and a y-intercept of 0, -4. So if I go to graph, I plot my y-intercept of 0, -1, 2, 3, 4, and a slope of 0. Recall that we get 0 if we do not rise anything, but we do run. So we rise nothing, but we do run something. I said it too, but it could really be anything. 4, 1, doesn't matter. 0 just means that we're not increasing or decreasing, we're remaining constant. So you can plot additional points, but what we see is all of these points form a horizontal line. From a table, you could think of this by plotting your y-intercept, so 0, -4, and say that the y values are not changing, so you increase by 0, or this remains -4. The other way to think about this is that the equation says y equals -4. There's no x in the equation, meaning no matter what x is, y will always be -4. Or in other words, y doesn't depend on x. Y is always -4. X doesn't impact y at all. So y is always going to be -4, no matter what x is. So this is what the table could look like. We set our slope and our y-intercept. We can also talk about the x-intercept. If we look at the graph, your x-intercept is where the line crosses your x-axis, but we see this horizontal line is parallel to the x-axis, which means they will never intersect. And so there is no x-intercept. So I'm going to write none. This is a horizontal line. It does not have an x-intercept. We can also think through this in the table. Remember, in the table, your x-intercept is where y is 0, but y is always -4, and so you're not going to have an x-intercept, because if y never changes and it's at -4, you're not going to get to where y is 0. Now I want you to use what we have here, that we talked about, in order to do the practice number 1 and 2. So pause the video, attempt 1 and 2 on your own right now. Now that you've attempted these on your own, I want you to check your answers with this video. If I want to graph y equals 3.5, I don't see an x. I know that y is always equal to 3.5. In other words, no matter what point I plot, it will have a y-coordinate of 3.5. If you find it helpful to make a table, you could make a table of x and y values, and you are literally putting 3.5 every time for y, and it doesn't matter what x is. So I could plot the point 0, 3.5, or 4, 3.5, or 8, 3.5. Or think of this as this has a y-intercept of 3.5 and a slope of 0. Again, remember y equals 0x plus 3.5, meaning we're not increasing or decreasing, we're remaining constant. So here is this graph. Down here, we see that this line is neither increasing nor decreasing. It is remaining constant. In other words, it has a slope of 0. So you can think of this, if you want to write it in y equals mx plus b, m would be 0. Our slope is 0 plus the y-coordinate of the y-intercept is 2. So you could think of 2, which we would just write as y equals 2. If you picked a few points on here, you could see what the table would look like. We have x and y. This is a point 0, 2. This is a point 1, comma 2. This is a point 2, comma 2. And we can see that the y value is always 2, no matter what the x is. And that is an indication that the equation will be y equals 2. Now, moving on to our next equation, we have x equals 6. This is not written in slope-intercept form or in point-slope form. We don't have a y equals. This is just saying x equals 6. So let's think through how we could reason through this. There is no y in the equation, which is telling the reader that y doesn't impact what x is. X will always be 6. So if I go to my table, I can say x would be 6 in each one of these values. It doesn't matter what y is, so we can choose anything. -2, -1, 0, 1, 2. Really doesn't matter. If I were to go create a graph here, I could plot the point 1, 2, 3, 4, 5, 6, comma -2, 6, -1, 6, 0, 6, 1, 6, 2. Now I've created a graph of the 5 points we have here, but we just chose those points. We could choose any values, right? We could choose y could be 4.5 and we're up here. Y could be -3.2 and we're right here. Really, there's an infinite number of points, but what we see is they will all lie on this vertical line here. So this vertical line is the equation x equals 6. When you look at the graph or look at the table, we see that the input of 6 has more than one output. In fact, it has an infinite number of outputs, which tells me that this is not a function. So recall, this line is not a function. Every other equation we've graphed so far has been an equation of a linear function, y equals something. This is not a linear function. This is just a linear relation. So it's not a function, it is just a linear relation. So recall the difference between function and relation here. So the slope, if we think about this, you can think of this as rise over run. You're rising something, but you're not running. So if I look at this, think of this as rise over run. If I think of rise over run, then I rise, let's say 5, but I don't run anything. Or you can think of the change in x over your change in y. So slope here would be change in y. Oh, sorry, I said change in x over y. Change in y over x, that'd be 1 over 0. If I punch 5 divided by 0 in my calculator, or 1 divided by 0, my calculator is going to say error. That's because we can't divide by 0. It doesn't make sense to divide 5 things into 0 groups. So here your slope is undefined. And we've talked about the slope of vertical lines being undefined. Looking at the graph or table, we can see that there is no y-intercept. The y-intercept of the table is when x is 0, but x is never going to be 0. It's always going to be 6. And we see that this vertical line is parallel to the y-axis, so the vertical line will never intersect the y-axis. Now it does have an x-intercept. The x-intercept will be 6, 0, because we cross the x-axis at 6, 0, or you can see that x-intercept in the table at 6, 0. So I want you to use what we summarized here in order to do the practice to the right, numbers 1 and 2. Please pause the video and attempt numbers 1 and 2, and then play the video again to check your answers. Now that you've attempted these on your own, let's think through x equals 0. Well, if I made a table, this would mean that x is always 0. Doesn't matter what y is. I can put any numbers in for y. If I were to plot those points, 0, 1 would be there, 0, 2, 0, 3, 0, 4. I notice that all of these points lie on a vertical line. That vertical line happens to also be your y-axis. So the y-axis actually has an equation of x equals 0. And there's my graph. Over here, if I write the equation of the line, I'm going to make this darker so we can see it. So this is the line that we're talking about. It's already listed a couple points here, but if we want to pick more points, and you make a table, if we're not sure how to write the equation, you get x and y. We have the point negative 1, 3. You have the point, this would be negative 1, 2, negative 1, 1. That would be negative 1, 0. This would be the point negative 1, negative 1. And what I notice is x is always negative 1. We have a vertical line where x is always negative 1. So if I want to write the equation, that equation would be x equals negative 1. Again, this is not a linear function. It is just a linear relation. So if we want to summarize this, if you look at the top, these graphs are horizontal lines. So let's summarize what we have here. On the front, we can talk about how if you have a horizontal line, your graph looks like this, and the equation is going to be, if we look at these equations, you just see y equals a number, you don't see an x. Y equals a number, you don't see an x. Y equals a number, you don't see an x. Because for a horizontal line, y does not depend on x. Y remains constant. So you're going to see y equals a number. In other words, there is no x in the equation. Whereas down here, these graphs were vertical lines. So a vertical line will be going up and down. So the graph will look like this. And your equations for a vertical line, well, let's think about this. If you have a vertical line, then x is remaining constant. It doesn't matter what y is. If x remains constant, does not depend on y, you're going to see x equal to some number. In other words, there is no y in the equation because x is not dependent upon y. If you change y, it doesn't impact x. So now we have our vertical line. Use this foldable now to work through the rest of the problems on vertical and horizontal lines.